Let's use this section to briefly discuss and implement the Telnet server, because there are instances where Telnet is desirable more so than SSH. So Telnet D, which features a clear text terminal emulator. It is the original terminal emulator for across-the-wire connectivity to hosts. Obviously, the original terminal emulator goes back to the days of true TTYs, and then pseudo TTYs, and then network TTYs. So it provides remote TTY or terminal connectivity to your Linux box. And the standard Linux server on any hardware nowadays can supply n number of terminal connections over protocols like SSH and Telnet. But the reason why Telnet still is important, despite the fact that it's clear text and has those inherent security problems as a consequence, is that some applications work better within the Telnet environment. I've seen firsthand key applications like time-based accounting applications that run on Linux that, for design reasons, do not work well with SSH and are tweaked specifically to work with Telnet. So there is still some sort of market out there in demand to be able to support Telnet. So let's set up some tasks, first of which is to install Telnet support and then test connectivity. Now we know Telnet, the client, is installed by default. How about searching? Let's aptitude search Telnet to see what's returned. A number of items come back. The package, which is, as you can see in its incarnation, a virtual package is called Telnet-server. And Telnet D is the actual package. There is an alternative Telnet DSSL, but if you use this, might as well use SSH. So if your application supports the SSL overlay, then you should be okay with the SSH framework. And there's some other packages. Now the Telnet client is installed. Its status is I, virtual, and these are programs that are not installed with the P prefix. So let's install Telnet D. Let's find our root shell, if not SU in, and this one is not in, so SU here. And then aptitude install. And again, you can either install the virtual package as it's named Telnet-server or simply Telnet D, either or. So let's install Telnet D and examine the configuration once it's completed. Again, everything is being pulled across the wire. And momentarily we'll have Telnet support. So now let's depackage list, Telnet D, and here is the footprint. So there's a user lib entry, Telnet login to allow logins, documentation, and the inetd managed binary. This is the primary program. So just like with TFTP, it's an inetd service. So inetd managed service. And this, between single quotes, is the primary binary that's called by inetd, which we can of course confirm by grepping telnet from etc inetd.conf, which is the main config file. So it's a TCP-based protocol, which means it's streams-based and supports multiple simultaneous connections, which means inetd spawns n number of instances for n number of clients. No waiting is necessary. It runs as root, managed by TCPD, and this is the binary that's called. Telnet binds to TCP port 23, so if we nets that, NTLP, of course it's managed by inetd, but nonetheless port 23 should be made available for this particular service. Now, whether or not it's actually running at the particular point in time is a separate question. Let's just go ahead and invoke RCD, inetd restart, and let's etc inetd, inet utilities, inetd restart, and then let's renet that to see whether or not it's listening. Now it's listening. So before with TFTP it was on the fly provision. In this case with Telnet it wasn't, but nonetheless just restarting inetd will do the trick. Inet utilities inetd. So here we have the PID 8835, which is responsible for port 23, which is bound to all IPv4 addresses. So it's available to accept connections, inbound connections. We should also note in standard Linux form root user may not, by default and by design, use Telnet. And that is because of the clear text transmissions of the root credential. So unless you modify the secure TTY file, you will not be able to allow root to log in. So it's installed, and let's just note what we indicated to install it. That was aptitude install telnetd, but we could have also installed the virtual package telnet-server. That's the legacy package. So another task for us now is to use the Telnet client to connect from various hosts. So to use Telnet, it's as simple as simply Telnet followed by the host name or the IP address. And that's it. Telnet defaults to port 23. The client knows to try to connect to 23 by default unless you indicate a different port. So to connect from a remote system such as build 1, let's SSH to Linux CBT build 1. And once there, we'll do a which telnet for the client. It's available in user bin, so it's always available. We'll then telnet back to Linux CBT deb1, which is at 7521. And there's the presentation of the shell. It produces the version of Debian GNU Linux. By the way, let's just navigate to etc and cat the issue file. This is read by default, returning the version to the standard out with a new line that's printed. And then let's log in as the user Linux CBT, clear text, which can be intercepted. And now we have a full telnet session whereby etc issue as well as MOTD are read and dumped to the screen. Let's just note, perhaps as a feature in the event that you need to display customized messages as per your compliance policy to your users, Telnet auto displays the contents of etc issue and etc MOTD. SSH can also be configured to display the contents of various files, issue, MOTD, and otherwise. So this is a connection. It's now bound to port 23. So let's ANT grep 23 and we'll see our socket. So from the remote system, high port 47888 connected to port 23 on our local system. And that's a simple telnet connection coming in. We can make use of the shell as we normally would with SSH. And oftentimes you'll find that telnet shells are fast because of the clear text communications. There isn't the SSH overhead, although the SSH server compresses the connection between the client and the server by default. So SSH sessions tend to be fast as well. Telnet tends to be very flexible. For example, if we're logged in supposedly, let's say from the remote system, let's drop this session here. Let's say we're on build 1, and then we decide to telnet to the default gateway, which is 75.1. If it'll accept our connection, it doesn't, then we'll SSH, and once there, it's currently disabled, that's why. Supposing we're at the router now, and we wanted to quickly telnet from here back to the remote system. Well, built into iOS for Cisco devices is a telnet client. And for later versions, like this version, SSH as well. But older versions of Cisco iOS don't have SSH client built in, so you'll have to use Telnet in that case. And that could be another means. So for example, if your day job is to manage routers and you're constantly connected to routers via Telnet and need to connect to one or more Linux systems, then Telnet server might be ideal for you. Not recommended, but maybe ideal. So let's telnet to the IP address 7521 from the perspective of the router. And there we see etc issue. And now we may log in as a user such as Linux CBT, for example. And so long as we authenticate successfully, we'll have a full session. And then, of course, a netstat ANT grep23 will show that additional socket coming in from the default gateway on a high port. So the router has sourced 35334 to connect to 23. Once completed with the session, simply exit, and then you're back within the context of the router, where you may make changes to the router as applicable. So the idea is that you can be on one device and connect back to another device using Telnet, similarly with SSH, but that's if SSH client is available. So in this case, as an option, let's just note B SSH to default gateway then telnet back to Debian box. But again, big caveat, note telnet is a clear text-based application. So this means communications between client and server is unencrypted, which means the traffic can be sniffed, which means credentials can be leaked, which means it's usually not a good idea to use telnet, but there are applications, and perhaps that's the exception. There are, however, applications that will not work with SSH terminal emulator, thus requiring telnet server. That's one reason why you may find it advantageous to use the telnet server on your Debian GNU system. But setting it up is rather straightforward. So long as you've installed the package, there will be an entry created in etc inetd.conf. And so long as inetd starts by default when the system starts, then you can expect the telnet server to start, as well as is the case with TFTP. So now we have two rather insecure programs being started whenever inetd starts. And in this case, telnet is set up to be run by TCPD and binds itself to port 23 and will accept connections appropriately. Now, if you do a man-in.telnetd, you'll see options that can be passed in to the startup of telnetd to control its behavior, whether you'd like to have debugging on or off if there are issues, for example, as well as other options. So it takes a number of options. And also, as mentioned, when we did an aptitude, in the event that your application will work with it, there is an SSL counterpart. Let's do a search for telnet to get all of the packages matching. And that's Telnet SSL. So if you wanted to try Telnet DSSL, this is a means of encrypting terminal emulations across Telnet as opposed to SSH. It effectively provides you with encryption like SSH, but not with all of the features that SSH provides, such as the ability to transfer files and run programs remotely without connecting to a pseudo terminal and the like. Now, just like with SSH, when you connect via Telnet, a pseudo terminal is generated. So from the perspective, let's say, of build 1, when we telnet back to 192.168.75.21, and once we've authenticated, let's connect in, you'll see that it auto-assigns the pseudo terminal that's next in line. So, for example, this is pseudo terminal 0, this is pseudo terminal 1, this shows up as 3 because of the multiple sessions, and then this is pseudo terminal 2, which is the next free session. So the same pseudo terminal generating function provided by the kernel is provided as well when we use telnet. So let's just note, perhaps as a feature, like SSH uses auto-generated pseudo terminals, which basically means entries in dev, PTS, and the number of the pseudo terminal. So it relies upon the same facility. Now, again, the warning is that if you don't need this clear text alternative to SSH, disable it. But there may be times where you need it and have to know how to quickly install it and take advantage of it. So that's a little bit about telnet. Let's move on to some other items.